For a while now, we have tools that promise that we can manage a fleet of Kubernetes clusters as one. Yet they all fail to do just that. They all failed to provide a single pane of glass for all the clusters in a fleet. All the tools I know eventually show us what is happening in a single cluster. And honestly, I don't need tools for that. I can easily see what's going on in a cluster with kubectl or literally any Kubernetes dashboard. What I'm missing and what all or almost all the tools I tried so far fail to deliver is a single pane of glass for all my Kubernetes clusters. Let's say that I have 10 clusters and I would like to see what's going on in all of them. As it is now, I would need to go to each of them separately and query each for information I need. Observability tools like Grafana, Prometheus, Jaeger, Loki and others help a lot, but they're focused on metrics and traces and logs and other data. And that's great, but that's not what I'm talking about today. GitOps tools like Argo CD could give me such a view, but they're all limited in terms of query capabilities. What I would really like is to use kubectl but treat all my clusters as one big, huge entity. I would like to have a single pane of glass. I would like to be able to say, give me all the deployments in all the namespaces in all my clusters, and bada bing, bada boom, all the deployments are shown in front of me. Actually, that's exactly what I'm going to get by executing this kubectl get deployments command. Look at that. Look at it. Isn't that impressive? I executed a kubectl command as I normally do, but the output shows deployments from 3 different clusters. There is DOT01, O2, and O3. Now, not only that I got all the information I need, but it was lightning fast. Whichever witchcraft ritual was performed for me to get that information, it is obvious that kubectl did not go to each of the clusters to get the data. That would take longer than it took. There's something else going on here, and that something else is a project called Clusterpedia. Clusterpedia, as you can guess from the name, is inspired by Wikipedia. It's supposed to act as an encyclopedia that contains information from all your clusters. We can use that information to search, to filter, to sort, and to organize data. Unlike some other solutions that typically fall into service catalog category, Clusterpedia is compatible with Kubernetes OpenAPI. That means that from the user perspective, it feels like all those clusters are one big cluster, and we can use kubectl or any other tool designed to use Kubernetes API. It looks and it feels like it is one big cluster, which is amazing, since more often than not, we tend to have many clusters for technical, performance, or security reasons. Yet, with Clusterpedia, we can work on all of them as if they are one big, huge, massive cluster. It's almost as if each cluster would be a separate namespace, except that they are real physical clusters. It is truly a single pane of glass. It's awesome. So let's take a look at it. Right now, I have 3 clusters running some resources and a 4th cluster where I installed Clusterpedia. It's just there, not doing much, not doing anything. I did not configure it yet, since I wanted to show you how we can let it know which clusters exist in our fleet and which resources should be observable through it. As a proof that nothing is yet configured, I can execute getpedia cluster, which should retrieve the list of all the clusters Clusterpedia is aware of. As you can see, Clusterpedia knows nothing about my clusters. We'll change that soon. For now, I want to show you a definition of cluster sync resources. It defines which resources should be synced into Clusterpedia. In this specific case, I decided that deployment services and ingresses should be synchronized always. Also, I defined that any resource that belongs to the DevOps group should be synced as well. So let's apply it. Now, that resource does nothing by itself. It's only a definition of sync resources that can be referenced in pedia clusters. It is meant to avoid duplication in cases when we want some, if not all, clusters to have the same list of resources that should be synced. Now, let's move into the real deal and take a look at the PDA cluster definition. That definition references one of my clusters. That reference is accomplished through the kubeconfig I would normally use to connect to that cluster. It enables Clusterpedia to communicate with that cluster and gather information about specific resources. Which resources it will fetch depends on us. In this specific case, I specified that it should use cluster sync resources we saw earlier. I could also specify sync resources specific to that cluster, but in this case, I chose to add none. Now, let's take a look at the specification of the second cluster. In this case, apart from the resources specified in the common manifest, I'm also saying that it should add all resources from the apps group and all resources that do not have any group specified. That would be resources like pods, for example. Then there are all resources that belong to networking K8s IO, Azure Upbound IO, and DB PostgreSQL Azure Upbound IO groups. Essentially, I'm saying that Clusterpedia should sync additional resources beyond those specified in the common list of resources. Then there is the manifest for the third cluster. Apart from the different name and kubeconfig, this third cluster follows the same rule as the second. So there's not much to say about it, for now at least. Let's apply those PDA cluster resources and execute get PDA cluster again. We can see that this time Clusterpedia knows there are 3 clusters from which it should sync resources. Now, the important note here is that everything is based on Kubernetes custom resources. As a result, we do not need any special tools, but simply use kubectl to query resources. And we're almost there. We are almost ready to use Clusterpedia as a single pane of glass for all our clusters. The only thing missing is to update our kubeconfig. Right now, if I return all the clusters defined in my kubeconfig, there is only one. That's the management cluster, the one where Clusterpedia is running. There is no information about any other cluster I have. For Clusterpedia to work correctly, kubeconfig should be updated with the information about all the clusters we can observe. Now, this is a good news, bad news type of situation. There is a way to add all the clusters automatically, automagically. That's good news. The bad news is that we need to execute a nasty hack to do that. I would have expected something more elegant than run this script from a Git repo, yet that's what it is, and I'll be brave. I'll be very brave and execute it. If I retrieve all the clusters from my kubeconfig, we can see that new ones were added, and we can see that there is also a mysterious Clusterpedia cluster. Now, none of those clusters are pointing to the actual clusters, but rather to special API endpoints in the management cluster, the one where Clusterpedia is running. I still do not have access to real clusters, no access for me, but I'm getting a convenient way to query information from specific clusters if I choose to do so. Let's see now how that looks like by, for example, executing kubectl, specifying that it should retrieve information from the cluster .01 and that we are interested in the list of all API resources available in that cluster. It seems that only a few resource types are available. I can guarantee that that cluster supports much more than services deployments, SQL claims, SQLs, and ingresses. Heck, according to that information, that cluster cannot even run pods. That's actually a proof that we are not querying the actual cluster, but information Clusterpedia gathered from that cluster. Those are resource types we specified Clusterpedia should gather from that cluster. We can see only what we told Clusterpedia we are interested in. Similarly, let's execute a similar command that will retrieve API resources from the .02 cluster. We can see that the list of resources Clusterpedia is retrieving from that cluster is much longer. That was to be expected, since for that second cluster we specified additional resources to synchronize. Finally, there is the special cluster called Clusterpedia. So let's see what that one sees as available API resources. That one represents a global resource information that is a union of resource types across all the clusters. Now that we saw which resource types Clusterpedia is aware of, let's do some querying. Let's say that we would like to retrieve all deployments from all the namespaces in all the clusters. We can do that by executing kubectl, specifying Clusterpedia as the cluster, and saying, hey, give me all deployments from all resources. Look at that. That's brilliant. That's exactly what I expected when I looked for a single pane of glass type of a solution. I can see the deployments from the .01, .02 and .03 clusters, and we did not have to do anything special. We used kubectl as we would normally do. The only difference is that we instructed it to use Clusterpedia cluster, which is not really a cluster, but rather a special endpoint in the management cluster, the one where Clusterpedia was installed. Now, let's say that I'm interested in pods instead of deployments. The command follows the same logic. Go to the cluster, Clusterpedia, and retrieve all pods from all namespaces. There is something suspicious in that output. There are pods from clusters .02 and .03, but not a single one from .01. Does that mean that there are no pods in that cluster? Well, no. That means that we did not instruct Clusterpedia to fetch pods from that cluster. If you take another look into Pedia cluster resource, the one we used earlier, you will see that pods are not in the list of resources it should sync from that cluster. That could be for security reasons, like maybe we do not want anyone looking at the single pane of glass to see pods, or it could be for any other reason. You are in charge of defining what will be synchronized. The point is that only resources we specify are discovered by Clusterpedia, and in case of .01 cluster, pods are not one of those. Any other kubectl command related to observability should work as well. We can, for example, ask the API to search all clusters, look only inside a team namespace, and retrieve all deployments. We can see all the deployments from the A-team namespace across all the clusters. We can even see that there is something wrong with how about this deployment in the .02 cluster by observing that 0 out of 2 pods are running. Now, what we saw so far is great, but that's only the tip of the iceberg. We can do much more by leveraging Clusterpedia's search functionality. The resources it syncs from clusters into its internal database are enriched with special labels which we can use as selectors when retrieving resources. For example, let's say that we are interested only in deployments with names equal to silly demo. We could get those with the same command as before, but augmented with --selector that filters resources so that only those with the label names set to silly demo are retrieved. And there we go. Those are all deployments with the name silly demo in the A-team namespace in any of the clusters. There are many other ways to search using the selector. For example, we can use the fuzzy name label to search for any deployment with the name that contains the word something. We can also say, hey, give me all the pods in the A-team namespace and filter the results by the field phase set to running. And there we go. Those are all the pods that are currently running, except for the pods in the .01 cluster, since we chose not to include those. So how about doing the opposite? We can use not_in operator to specify all the pods with the phase that is not set to running. Those are all the pods in the A-team namespace that are not currently running. What else? We can also use the clusters label with the in operator to say, give me all deployments in the A-team namespace that are running in clusters .01 and .02. And there we go. Here's another good one. It's not only that we can see the current state of resources in any of the clusters, but we can also go back in time. We can, for example, ask Clusterpedia for all deployments that were created before certain date. Now, that did not produce any results since I created those clusters after 1st of January 2024. If those were running before that date and Clusterpedia was collecting information, we would be able to see which deployments we had at that time. Similarly, we can do the opposite and ask it to give us all deployments from all namespaces that were active since a specific date. And there we go. Those are all deployments in all namespaces since January 1st, 2024. Now, those outputs might be sometimes chaotic, so we might want to order them. We can do that through the order by label by saying order it first by cluster and then by namespace. And there we go. This now makes more sense, or to be more precise, this output with everything sorted by cluster and then namespace might be easier to digest. By the way, if you go to the documentation, you should be able to see all the different things we can do with the search. I strongly recommend spending some time studying it. Now, to be clear, Clusterpedia is not limited only to resource types baked into Kubernetes like those we explored so far. It can fetch and organize any type of resources, meaning that custom resources are available as well. For example, I can retrieve all SQL claims which are custom resources based on a custom resource definition I created through Crossplane. Now, unlike resource types baked into Kubernetes, custom resources are a hit and miss type of situation. As we can see, they are there, but Clusterpedia did not preserve all the information. If I would have executed the same command against one of the actual clusters where those resources are running, the output would contain a few additional fields. By default, Clusterpedia knows only about the cluster, the name, and when it was created. And that's a shame. I would have expected it to fetch the schema of the CRD associated with that resource and deduce which fields should be stored in its internal database. That can be fixed by giving Clusterpedia additional information about those resource definitions, but doing that is tedious and, frankly, too much work, unless we are talking about only maybe a few CRDs. Finally, the important thing to note is that Clusterpedia is all about observability, not synchronization. We cannot use it to apply new resources, to edit existing ones, or to delete them. Some might find that to be a problem, but I believe that's the right decision. We have plenty of tools that can be used to manage resources in a single cluster or access a fleet of clusters. What we do not have is a single pane of glass that provides visibility into all the resources across clusters. That's what Clusterpedia does, and there is no good reason, as far as I'm concerned, to go beyond that. And now that we explored Clusterpedia from the user's perspective, let's take a quick look at its architecture. We have a number of clusters, 1, 2, 3, etc., etc. Those are clusters where we apply Kubernetes resources that do something, be it for applications running in containers, Crossplane resources that manage external resources, KubeVirt resources that manage virtual machines, or anything else. It does not matter what's in those clusters. What does matter is that there is more than one Kubernetes cluster and that we would like to observe them through a single pane of glass. Further on, we have a management cluster that might also serve to run workloads or anything else. It is a Kubernetes cluster like any other. What makes it special is that it will serve as a single pane of glass through Clusterpedia. Finally, we have a database that serves as Clusterpedia storage, in a similar way as etcd serves as storage for Kubernetes state. With all that set up, we instructed Clusterpedia how to synchronize resources from those clusters. From there on, those cluster synchronizers started pooling data for resources that match specific resource types and storing that data in the database. Further on, Clusterpedia exposes an API that is compatible with Kubernetes API. When we send requests to Kube API, those requests are actually handled by Clusterpedia API, which gets data from Clusterpedia itself and returns responses to us. The whole process is pretty similar to how Kubernetes works, except that data is not stored in etcd of each individual cluster, but in a central database. As a result, we get much richer search and filtering capabilities, and we get historical data. Queries are much faster, in part because the database is not etcd, but Postgres or MySQL, and because all the data is in one central location. Now that we saw Clusterpedia in action and we had a quick walk through its architecture, we can finish the discussion with pros and cons. There are very few negative things I can say about Clusterpedia. It's awesome and I strongly recommend it. But if I would have to pick a few bad things to say about it, the inability to show info related to a CR is a big one. As I mentioned before, we could instruct it to fetch and present more info, but that's more work than I feel we should put into it. Another potentially big problem is related to duplication. If each cluster stores all the info in its own etcd, copying that info into Clusterpedia's internal database is a waste. That might not be such a big issue right away, but when working on a larger scale and dealing with many resource types, we might experience a more visible performance penalty. Clusterpedia is more or less efficient. Still, having two instead of one internal storage etcd in each cluster plus Clusterpedia as DB might prove to be a bit too much. Now, I'm fully aware that Clusterpedia could not be querying etcd directly. That would be slow, especially since etcd is one of the biggest bottlenecks in Kubernetes, even without Clusterpedia. So, the decision to keep a separate database is a good one. Nevertheless, a better one would be to get rid of etcd altogether. That, however, would be a subject of a completely different video. As for the pros, the most important one is that Clusterpedia is the first time I saw a single pane of glass that works on that level. Sure, we have a way to provide a single pane of glass for metrics, logs, traces, and other types of data, but not in terms of having a Kubernetes native single pane of glass that exposes everything as Kubernetes API so that we can use familiar tools like kubectl to observe what's going on. While there might be other similar solutions, this is the first one I discovered that makes a fleet of Kubernetes clusters feel like a single cluster. On top of that, we have search, filtering, and ordering, which might not be the most powerful, but are excellent features nevertheless, since they are exposed through familiar mechanisms like label selectors. Finally, the fact that Clusterpedia functionality is exposed as Kubernetes API, or to be more precise, in a format compatible with Kubernetes API, we can leverage the same tools as we normally do. Today I showed how we can leverage it with kubectl, but there are many other ways. Essentially, any way that would normally work with the standard Kubernetes API will work with Clusterpedia. We could, for example, write code that does something on the fleet level by using the same libraries we would normally use to interact with Kubernetes API. And that's it. Thank you for watching. See you in the next one. Cheers.